Black holes and galaxies coexisted in early universe. Black holes and galaxies existed together during the first 1% of our universe's existence. Find out why this upends conventional thinking on how stars, galaxies, and black holes formed after the Big Bang. Like a lot of folks my age, the first time I heard the term black hole was because of the 1979 Disney film with that title. It was kind of a Me Too version of Star Wars and Star Trek. The critics panned it, and nobody seems to remember it anymore. A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. The first person to think black holes could exist was John Michell in 1784. He calculated that a supermassive star would have so much gravity that its escape velocity would be faster than light, making it invisible. The idea that there could be invisible stars hiding in plain sight seemed intriguing to astronomers. On the other hand, the debate between those who thought light was a particle and those who thought it was a wave made the theory hard to confirm. Einstein's general relativity theory provided a solution to the black hole puzzle, although he personally argued against them. In the 1930s, Subrahmanyan Chandrasekhar, Robert Oppenheimer, and others calculated that neutron stars beyond a certain mass would collapse, based on Einstein's equations. The first observed black hole, in 1971, was the powerful X-ray source Cygnus X1. In 2019, the Event Horizon Telescope captured the first image of a black hole in the galaxy M87. NASA's James Webb Telescope's mission is to enable scientists to look further back in time and understand the formation of galaxies and black holes, not to mention the universe itself. Now, a new analysis of data from the Webb telescope has upended the conventional wisdom on galaxy and black hole formation. For more than 5 decades, Dr. Joseph Silk has been a distinguished scholar in cosmology, including galaxy and star formation. He won the 2011 Balzan Prize for his contributions toward explaining the early universe, and he's currently a professor in Johns Hopkins University's Department of Physics and Astronomy, and at the Sorbonne in Paris. Professor Silk is the lead author of a study that Astrophysical Journal Letters published this week. His team reviewed data about distant galaxies from the early universe, trying to understand why they're much brighter than scientists had expected them to be. Astronomers had believed that black holes formed after supermassive stars collapsed, and that galaxies evolved later. However, the researchers' findings indicate that galaxies and black holes coexisted in the same time period. We know these monster black holes exist at the center of galaxies near our Milky Way, but the big surprise now is that they were present at the beginning of the universe as well, and were almost like building blocks or seeds for early galaxies, Professor Silk explained. They really boosted everything, like gigantic amplifiers of star formation, which is a whole turnaround of what we thought possible before. So much so that this could completely shake up our understanding of how galaxies form. Based on the team's findings, both black holes and galaxies existed and influenced one another as early as 100 million years after the universe began. That's so far back that it represents less than 1% of our universe's current age. We're arguing that black hole outflows crushed gas clouds, turning them into stars and greatly accelerating the rate of star formation, Professor Silk said. Otherwise, it's very hard to understand where these bright galaxies came from, because they're typically smaller in the early universe. Why on earth should they be making stars so rapidly? The researchers proposed that the early universe went through 2 phases of development. In the first phase, high-speed outflows from black holes sped up the formation of stars. These outflows slowed down during the second phase. The magnetic storms from supermassive black holes caused enormous gas clouds to collapse, creating new stars at a much faster rate than astronomers are used to seeing today. The Webb telescope only launched a couple of years ago, so scientists are expecting a lot more data from it. Professor Silk's team believes that the telescope will deliver more precise counts of stars, black holes, and galaxies that will confirm and refine their models. Getting to the bottom of our universe's early formation addresses our need to understand the world around us and our place within it. Even so, scientists are still a long way from finishing the new story we're all hoping to learn about how it all began. The big question is, what were our beginnings? The Sun is one lone star in 100 billion in the Milky Way galaxy, and there's a massive black hole sitting in the middle, too. What's the connection between the two? Professor Silk concluded. Within a year, we'll have so much better data, and a lot of our questions will begin to get answers. We always have more to learn, if we dare to know.